Today's notes, 2.4, distribution shapes. So the goal for today's lesson is to be able to identify the shapes of data distributions, positively skewed, normal, or negatively skewed. So it's actually important to be able to distinguish the shapes of our quantitative data and their distributions, whether it's a frequency distribution displayed on in a histogram or a dot plot, any of the types of displays that we've talked about. It's important to be able to look at that display and kind of estimate the shape so that we can further analyze that data. So to identify the shape of a distribution, the best approach is to use a curve that approximates the overall shape. Not just any curve, a smooth curve. So you can see you've got this line, the smooth curve, that's actually outlining the histogram in figure 2.10 here. Examining the shapes of distributions. So we have a few different categories that we look at in terms of the shape of the distribution. The first is modality, the second is symmetry, and then the third that we'll take a look at is skewness. So first looking at modality. So to determine the shape of a distribution, observe its number of peaks or highest points. Notice there is one highest point, unimodal. That means uni means one. Bimodal, you can see there are two highest points. Bimodal, two. And then multimodal, you can see there's multiple peaks there. Multimodal makes sense. Next is symmetry. So distribution that can be divided into two pieces that are mirror images of one another has symmetry. So you can see our three different categories for symmetry would be bell-shaped. So you can see makes that nice smooth curve with the unimodal, one peak in the middle, and then the triangular symmetry, and again this one is unimodal, and then uniform or rectangular. There are no modes here. So next up is skewness. So we have here skewness in terms of our histogram here that is negatively skewed or left skewed. You can tell that there's like a trailing off on the left hand side. In other words, the tail, I put a whale over top, so the whale's tail is on the left hand side there. It's to help you remember left skewed. In these data sets, the mean would fall to the left of the median, and the mode, the one that the observation or data point that occurs the most often, falls to the right of the median, so the middle point. You see here that would indicate the mode. So if you can picture our dot plot or our frequency distribution, the one that occurs the most often has the highest bar. Positively skewed or right skewed distribution, you can see in the diagram the tail is on the right, it trails off to the right. In this case, the mean falls to the right of the median, and the mode, the one that occurs the most frequently, occurs to the left of the median. It's the high bar. And lastly, the symmetrical distribution. So in this case, the symmetrical distribution, the data values are evenly distributed on both sides of the mean. Now, it doesn't have to be exact when we talk about the symmetric distribution, but it does look very close to being bell-shaped as this symmetric distribution looks. Last topic for today is population and sample data. So you can see with the population data, the values of a variable for the entire population. In other words, a census. Most often we're actually talking about sample data, the values of a variable for a sample of the population. So as you can see here in this image, we have a graph that demonstrates the population distribution, right? Number of people per household, and then we've got the relative frequency for the number of people per household. You can see that 2 people occurs most often, 7 people per household is the least frequent number of people to have per household. So this is the overall population. This is if I did a census of the entire population. And then you can see 6 different sample distributions. If you look at a quick glance, you notice that the shapes are very similar, right? They would all be considered right skewed. If we drew that curve over each one. But you can tell very quickly here that there are no households in this sample that had 7 members. Whereas the number of households with 1 person stands here at about 33% or 33 hundredths of the people, almost a third, and then over here it's close to 26% for the entire population. So I think it's just interesting to note within your sample distributions, they should look similar to the population, but there's no way they can be exactly the same. You're just choosing a sample of people and trying to determine approximately how many are in the population. So the reason we do this, we find these samples, is because we rarely actually know the population data, right? We've talked about taking a census is a very time-consuming and expensive process. So oftentimes we are left to find samples of data and use that to make an inference about our population.